Okay, we're back to do this problem again. I apologize for feline interference that had to be cut, so we're going to do problem 6 and 7 now. Okay, previously we were talking about this formula and how we're going to apply it. So let's go ahead and do the two problems which use it. So first things first, let's do number 1 at the bottom of page 6. This is a sociologist wanted to determine the percentage of residents of America that only speak English at home. What size sample should be obtained if she wishes her estimate to be within 3 percentage points with 95% confidence, assuming she uses the 2000 estimate saying that 82.4% speak only English at home. So first things first, that 3 percentage points error needs to be converted into decimal form, so that's 0.03. 95% confidence. What's my critical value there? It's 1.96, so you can either use your table, you can look it up in the Z-chart, or you can go 2 pages up right now. It's also there. And we are assuming p hat is 0.824, which means 1 minus p hat is 0.176. So now all we have to do is put all of these things into the equation. N equals 0.824 times 0.176 times 1.96 divided by 0.03 squared. And when we put that in, we get 557.472. Now, obviously our survey cannot ask 557.472 people. To be safe, we always need to go out from there to make sure our bases are covered. So you always round up to the next whole number. So that would be at least 558 people to be within 3 percentage points. At 95% confidence. So these aren't too bad. It's just about making sure you convert your E to decimal more than anything and you have the right critical value. So let's see what happens if we don't actually know, because we talked about this in the last video. What if we don't know, don't have a previous estimate to help us, and we're doing it blind? So that's the problem on the next page. So instead, she wants to determine the same things, still within 3 percentage points, still with 95% confidence, but she doesn't have a preliminary idea. So 2 on page 7 is the same thing with no preliminary. Same thing with no preliminary estimate. So instead of using that 0.824 from up there, now both of these are going to have to be 0.5. So same E, same Z alpha over 2. But now p hat is 0.5, and 1 minus p hat is then also 0.5, because it's 1 minus a half. So the only thing that will change is now n is equal to 0.5 times 0.5 times 1.96 over 0.03 squared. Now this should go up because this is the biggest it can possibly be. So let's see what it is. It looks like I got exactly 961. Well, that's interesting, but works for me. Okay, so what happens here? 961. How does that compare? We needed a lot more people. That's because we didn't have any knowledge going in of what we expected it to be. So in order to cover our bases, we needed more people. So at least 961 people, in this case, to be within 3% at 95% confidence. So those are confidence intervals. They work a lot off the stuff that we've already done. So it shouldn't be too bad because it's just like having the bounds from our previous chapter where we go up and down z-scores. So it shouldn't be too bad. You'll notice there are 9.2 notes listed in there, but 9.2 has actually been eliminated because we lost our week along with some things in chapter 10. So this is the only thing from chapter 9 that we're going to do. And so that's it. So I hope you enjoyed it, or it's passable, but we'll keep going next time, starting next week with 10.1.